Hey all, in this video we're going to be showing off our final project for CS1680 networks, in which we build on our existing IP TCP implementation in order to connect it with the real network and the broader internet. In this first clip, I am having netcat listen on my real computer on port 1234, and then I'm going into our IP TCP implementation and connecting to it. Here we see I'm connecting to IP 10.7.0.1, which is the IP of my real computer within our virtual network. This successfully establishes a socket between our virtual host 1 and the netcat running on my real computer. This allows us to send data back and forth. Next up, I'm setting up a listener on our host 1 and then connecting to it on my real computer with netcat. Here we see that I'm also able to establish a connection in this direction, creating a socket and allowing us to once again send data back and forth. Next up, we're establishing a connection over a real network, in this case the Brown network, although it would work similarly over the real internet. Here, on the right, Alex's computer is shown over Zoom. Here we see that from virtual host H2, we're able to establish a connection over the Brown network to Alex's computer to his netcat instance running on port 1001. Similarly, we can go the opposite direction. Here, I first use the port forward command built into our virtual router in order to forward this IP on our virtual network to the real network. Then I open a listen socket on virtual host H2 and have Alex connect to it from his computer. Here we see we can successfully send and receive data over Brown's network. Next, we go the other way. First, we see that Alex has port forwarded his virtual network to his real network using Docker. Now we see that he is listening on port 1000 with VNC, which is our virtual implementation of netcat on top of our IP TCP stack. Then I connect using our virtual netcat on my computer, and we are once again able to communicate. Now for the fun part. Here, I'm running our HTTP server that is built on top of our IP TCP stack, and then I connect to it with my web browser. Using the single TCP connection to our web server, we're able to browse around the website and even view large files such as PDFs. Furthermore, Alex, on a different computer on the Brown network, can connect to the server and browse around and even view large files that are sent over the Brown network from our virtual stack. Now, at the same time, Alex is running an instance of our HTTP server on his computer through our virtual network as well. And just as well, I can connect to that server from my computer. Finally, here's a brief proof of concept of dynamic content working on our web server. Here, Alex is hosting another instance of our HTTP server on port 81. I then send a post request to the server, and in response, the server dynamically loads a page that displays the content I sent. This demo shows that we're able to have our TCP IP implementation not only interoperate with traditional operating system TCP implementations, but also that we can serve real data and host websites on our TCP stack over a real network, and even over the internet.